We're going to look at inverse functions. When we talk about inverse functions, what we're looking at is that the two functions f and g are inverses if and only if f of g is equal to x and g of f is equal to x. This is going to give us if they're inverses of each other. When we talk about inverses, inverse functions are those in which it's a one-to-one function. So first of all, both of these functions have to be one-to-one. And then what we're doing is we are interchanging the x's and y's, and we're solving. So when we are given two functions, in order for us to determine if they are inverses, we have to do the composition of the functions. Now, just because one comes out to be x does not indicate that they will both come out to be x. So you do have to prove both f of g is equal to x and g of f is equal to x. In other words, you have to prove that it works both directions. So let's look at what this actually means. If I'm looking at the two functions, f of x is equal to a 3x plus 6 and g of x is equal to a 1/3 x minus 2. So these two functions, what I'm going to do is I'm first going to do f of g of x. So this means that I am going to put the g function inside the x of the f function. Because remember, in compositions, you're always putting the second function inside of the first. So I'm going to have 3 times, and in place of that x, I'm going to put this entire 1/3 x minus 2. One of the big things though, don't forget that plus 6 out there. So I should have 3x, so 3 times my g, plus 6. I distribute my 3. 3 times 1/3 is just 1, so that gives me just an x. 3 times a negative 2 will give me a negative 6, plus 6. Negative 6 and a positive 6 subtract out, so that gives me just an x. So yes, f of g of x does just equal x. So that means that now I have to prove it g of f of x. So I'm going to start with my 1/3, and in place of my x, I'm going to put the entire f function, 3x plus 6. And then I'm going to have the minus 2. When you're multiplying by fractions, remember that you're basically just doing a division. So 1/3 times 3 will give me a 1. So that'll be 1x. 1/3 times a positive 6 is the same thing as saying 6 divided by 3, which will give me a positive 2. And then I have that minus 2 sitting out there. The positive 2 and the negative 2, they will subtract out, and I'm just left with an x. So yes, these two are inverses of each other. Now I'm going to do a couple of other examples to show you what happens if they are or are not. Okay, so let's start with if I have f of x is equal to a negative 12 minus 2x divided by 3. And then I have g of x is equal to a negative 5 plus 6x divided by 5. So whenever I do the f of g of x, that means I'm going to start out with my f, so negative 12 minus 2, and in place of my x, I've got to put this whole thing. Negative 5 plus 6x divided by 5. And then that's all over 3. So, whenever you have a fraction within a fraction, in order to get rid of this denominator right here, what you want to do is you look at, I have a term here. I basically have a term here. And I'm going to multiply both of those by that 5. Because I'm looking at that numerator. And I can multiply both of those by 5. And I also want to multiply my denominator by a 5. I want to multiply through by that denominator to get rid of this denominator. So what I'm going to do is I'm going to multiply through by a 5. That will help get me a little bit neater fraction here. So when I multiply through by a negative 5, this is going to give me a negative 60 minus a 10. Now where I multiply and I apologize, that should only give me a negative 2. Because what I was about to say is where if I multiply this by that 5, those divide out. And so I'm left with negative 2 times a negative 5 plus 6x all over 15. I distribute the negative 2. And so that will give me a positive 10 minus 12x divided by 15. And I combine like terms, so that'll give me a negative 50 minus 12x divided by 15. And I notice there's no way this is going to simplify. Because I can divide these two by 5, but this 50 is not going away, and these two aren't going to simplify out. So these two are not inverses of each other. Okay? And again, once you get one of them where it's not dividing down to the x, then you can check yourself with the second one, but you don't have to. So this is looking at how to find if two functions are inverses based on their composition of functions.